What's up, guys? I hope you are all doing well as you come to this video here, which is going to be about both the law of sines and the law of cosines. Now, this is the third in a series of videos that I've made on law of sines and cosines, where the first one was just about law of sines and the second was just for the law of cosines. But here, we're going to be integrating the two skills, the two concepts together, and making sure that you can identify when to use which particular law. So for law of sines, there are three sets of parts that we can look at, and we did talk about this in both the law of sines and cosines videos about when to use it. We can use the law of sines when I have the combination of an angle, an included side, and another angle. When I have an angle, and a non-included side. And when I have two sides and a non-included angle. And this is the one that you need to pay attention to at some point because that one has potentially more than one solution, which is why that combination of parts was never able to be used to justify when triangles are congruent to each other. And for the next one, for law of cosines, there's essentially two times when we're looking for, or two sets of parts that we can use when we have to use law of cosines. That's when I have a side, an included angle, and another side, and all three sides, side, side, side. And usually on this one here, usually if we're doing side, 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 we want to find the biggest angle first. It'll just make things easier when we look at it like that. So find the biggest angle first. Now, the one thing that we haven't talked about is, what about angle, angle, angle? What if I have three angles? Well, angle, 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 unfortunately, cannot be used for anything other than showing figures are similar to each other. So angle, angle, angle will never be used. This only shows similarity. So an angle, angle, angle combination is never going to be used for anything but similarity, definitely not for law of sines or law of cosines. So what we're going to be looking at with our example problems today, there are 8 problems that we're going to take a look at where you have to make the determination based off of what they're giving you in the problem. Are you going to use law of sines or law of cosines? And here what it says solve each triangle. Basically, when it says solve the triangle, it's asking you to find everything that's not provided for you. So any missing angle measurements, any missing side lengths, anything that you can find on the triangle, find on the triangle. So let's see if we can zoom in a little bit here and make it a little easier to see what's going on. Looking at the figure that we have in example 1, in this case, they've given me a side, an included angle, and another side. So here this looks like we're going to be using side, angle, side, which indicates that we're going to be looking at the law of cosines. Now I can't use the law of cosines to find these missing angles here straight away. Instead, one of the things that I want to be able to do is I want to be able to find the length of that third side. That's one of the things that the law of sines is going to allow us to do. So let's call this little g, since that is opposite of angle g. So in this case, we can kind of adapt the law of sine or law of cosines that we have here, to represent angle A or angle E, angle F, and angle G along with the sides. So here, this side would be side F, and this side would be side E. So I'm going to look at the law of cosines as saying I'm going to find side G by saying, and I like to start it off with the square roots. I'm going to take the sum of the two squares of these things, which would be a 7 squared plus a 10 squared minus a 2 times those two numbers, 7 and 10, times the cosine of the included angle that they gave me, in this case 132. And I'm going to just go to my calculator and let it do the heavy lifting here for me. And again, make sure that your calculator is in degree mode. And when I type this on my calculator, let me turn my lamp on so it's a little easier to see the display. If I say the square root of 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 132 degrees, we get a side length of about 15.578. Now, right now, I'm going to go ahead and save that number just in case I need it. Okay, so I'm going to save that number on my calculator, and I'm going to say that side G is approximately equal to 15.578 units long, which happens to be side EF here. So we can put that answer here, 15.578. Now that I have that, we can try to figure out what the measurements of the missing angles are going to be. We need to be able to find the measurement of angle E and the measurement of angle F. So angle E is kind of the next one down in the list in this little column that we have here. So let's look at focusing on finding angle E. Okay. Well, now that I have all three sides of the triangle here, we can start. Let me just go ahead and put this here. This is going to be equal to, what do we say? We'll just say about 15.6 here, just to save some space. Okay. So now we have the measurement of all three sides, and we're looking for the measurement of some kind of an angle here. So if I want to find the measurement of angle E, we know the side opposite of it, and we know this angle, and we know the side opposite of it now. So if I know a ratio of a side and an angle and another side and an angle, that means we can use the law of sines to find the measurement of angle G. So for angle G, I'm sorry, not angle G, angle E. So for angle E, I'm going to use the law of sines. So here I'm going to say sine of angle E over the side opposite of it, which is 10, is equal to the sine of the 132 that we got, or that was given to us, over the 15.578. 15.578. So multiplying by 10 on both sides will give me the sine of E to be equal to 10 times the sine of 132 over the 15.578. And we're not looking for the sine of E, we're looking for the measurement of angle E. So here I will say E will be equal to the inverse sine of the 10 sine of 132 over the 15.578. Let me go ahead and zoom in just a little bit here so we can see the numbers okay, because I can just kind of move back and forth. So now on my calculator, I've saved that number. Okay, so if I hit where I stored it, if it's going to come back up. So on my calculator, I saved it in memory spot X, but that's just how my calculator has it saved. Obviously, yours may be different. So here I'm going to say inverse sine and hit my fraction button, and I'm going to say 10 sine of 132 over that number that I have saved. Oops, not that one. Oh man. All right, 10 sine 132 over the number I have saved. There we go. And I'm going to hit enter, and I get about 28.5 degrees. So E is about 28.5 degrees. Now, to find the missing angle measurement here for angle F, we really don't have to do any work. We really don't have to show work necessarily. We just understand that the sum of the three angles are going to be 180. So since they gave us the first angle to be 132, we'll just go straight to our calculator. Now, since I still have that number there, I'm going to go ahead and use the number that the calculator gave me, and I'm going to say 180 minus the 132 that was given to me in the triangle, minus the 28.5 that we got from the law of sines, and I'm going to get an angle measurement of about 19.5 degrees. So here we have 19.5 degrees. And this is how we're using the law of sines and the law of cosines, in this case, to solve the triangle. Starting off, we had to use the law of cosines to find the missing angle measurement. I'm sorry, the missing side length that wasn't given to us. And then we had to use the law of sines with the number that we got to find one of the two missing angles. And then we could just subtract the two angles that we know in the triangle to find the third one. So that's what it means when it says solve the triangle. We basically want to be able to find anything in the triangle that we can find. Pardon me. So let's take a look at the second example, and I'll see if we can do, if you guys can do the third one on your own. So we'll go ahead and put them here so we can see them. And what we're looking at here, they're giving us an angle, and a side that's not in between the two angles. So here we're looking at, they're giving us an angle, side. So clearly we can use angle, side with the law of sines. And what we're being asked to find, we're asked to find the two missing sides, LM and MN, and then find the missing angle. Well, the missing angle is going to be the easiest thing to do because they've given us two of the angles already. So if you just subtract the 129 and the 21 that was given to you, you're going to get this angle here to be 30 degrees. There's really not much work that we have to do on that one. We're just subtracting the two angles that was given to us from 180 degrees. So now how are we going to find the missing side? So here we'll call this side little m, and we'll call this side little n. And those are going to be the two sides that we're going to be looking for. And because we know that this angle here is 30, we can use the ratio of the angles, the angle here and this side, the angle here and this side, and we can use that to find side n, which is LM here. And we could do the same thing to find, and so this side would be side L, so little l. All right, so let's figure out what we want to get first. So let's find segment LM, which I have here is labeled as N. Okay, so I'm going to say the sine of 30 degrees over the N, which we don't know, that's what we're looking for, is equal to the sine of the given angle 129 over the given side length of 5. So when we cross multiply here, we're going to end up with 5 times the sine of 30 over the sine of 129 to be equal to the side that we're looking for, in this case. And here you go to the calculator and just see what it tells you. So I'm going to look at hitting my ratio button, 5 sine of 30 divided by the sine of 129, and here we get about 3.2 units long. We don't know what the units are going to be, but it makes sense. Here, the 129 is clearly the biggest angle, so this is going to be the biggest side, so both this side and this side should be less than 5. So here we're going to say about 3.217 is approximately equal to that side. So we'll put the 3.217 here. Well, now we want to be able to find the third side. Now remember, this is not a right triangle, so we cannot use the Pythagorean theorem, but I can use the law of sines one more time to be able to find side L. So here I have the sine, so we'll kind of separate the space here. I have the sine of the 21 degree angle over side L to be equal to same ratio, sine of 129 over the 5. And again, we'll cross multiply, and when I do, I'm going to wind up with 5 times the sine of 21 divided by the sine of 129 to be equal to side L. And again, we'll just go to the calculator here, and because this is the smallest angle, this side L should be smaller than this side N. So side N was just over 3, so this should be something less than 3.2. So let's see what the calculator gives me, and hopefully we did everything correctly. So I'm going to say 5 times the sine of 21 divided by the sine of 129, and 2.306. We definitely got something smaller. So 2.306 is approximately equal to that third side, 2.306. And there we go. So like I said, it's just a matter of looking to see what did they give you to start with, what combination of parts, and then determine, well, from this combination of parts, we can use either the law of sines or the law of cosines to, find something about the triangle. And then once I have that, to find any of the missing parts, we can maybe use just, triangle sum theorem, or maybe we have to use the law of sines or something else. So think your way through the problem. So at this point, try working out example 3 on your own, and when you're ready, hit play and check your work with mine and see how the answers compare. Alrighty, and here we go. The first thing that I did was made a mistake, and you can see that I whited it out. So the second thing that I did was recognize, because we're looking at side angle, that tells me I'm going to be using the law of sines in some capacity. And with the ratio that they're giving me of this angle to this side, I was able to find this angle because they gave me this side here of 17. So sine of 98 over 28 is equal to sine of x over 17. And here, solving for x, when I do the inverse sine, I get about 36.96. Now here, I didn't want to round it up to 37 because it wasn't exactly 37, and I definitely saved this number on my calculator. And what I did is I took this number, what I saved on my calculator, and I subtracted it along with the 98 degrees from 180 to get this 45.04 degree angle here. And once I have the 45.04 degree angle, then I can find the side opposite of it, which in this case I called side W because it's across from angle W. And I can use the law of sines here. Sine of the 45.04 over W is equal to sine of 98 over 28. Solving for W in this case gives me just over 20.008. And this is this is part of the significance of why you make sure that you save your number on your calculator, because you only give your final answer rounded here. You try not to avoid any kind of rounding or doing any kind of calculations with rounded numbers, because that introduces something called rounding error, and your decimal value will be off, and that can cost you points on tests. So there's the first three. Pay no attention to the scratch work that I have underneath here. We don't need to be doing any calculus. Oh, and more calculus. We don't need to be doing that. So let's move on to our next example here, where again it's just a whole bunch of can you find the measurement of the indicated parts. And I would say that at this point here we should be able to do examples 4 and 5 on our own, but I'll go ahead and do 4 with you here because we're clearly looking at side, side, side on this one. So that tells me that we're going to be doing law of cosines here to be able to find some angles. So side, side, side. And if you refer back to the video that I made on law of cosines, one of the things that I did is I said, well, you can find the measurement of an angle. So for instance, let's find the measurement of angle A. You can find the measurement of angle A by saying the inverse cosine of whatever side B squared is plus whatever side C squared is minus the side A squared, and all of it divided by 2 times B times C. This is all we did to get this was just do a little bit of algebra with the law of cosines problem that we had to be able to get this. And now I'm going to go ahead and use that to find well, let's find side angle A. Since I already have it written there, let's just go ahead and start plugging in our values here. If I want to be able to find angle A, I'm going to say inverse cosine. And substituting my numbers here, B squared would be the 29, so 29 squared, plus C squared. C squared is going to be the 24, so 24 squared. And A squared, obviously, is going to be the 14, so minus 14 squared. All of it divided by 2 times 29 times 24. And this is where the calculator is going to save us a lot of work. We'll go to our calculator and just type in the ratio. So here, inverse cosine, and I'm going to hit my ratio button, 29 squared plus 24 squared minus 14 squared, all of it divided by 2 times 29 times 24. And in this case, I am getting an angle measurement of about 28.7 degrees. So 28.7 degrees. And I'm going to save that number on my calculator, because by itself, so we'll just say, I'll go ahead and put the 28.7 here. Because by itself, that is not necessarily enough to get the other angle measurements. Now at this point here, you kind of have a choice of, I can use this ratio here of the sine of the angle and the given side to use law of law of sines to maybe find this angle or this angle here. Or you can continue doing law of cosines to find another angle. And some people are going to say, well, it would be better to use law of cosines because that way you avoid doing any math with a calculated number. Because even if I save this number, what if it was wrong? What if I made a mistake getting this number and then I do more math with it? You know, that could compound my error. Now you could always check. You could do the law of cosines and the law of sines to find the same angle, and they should be the same. But I will kind of leave it up to you. I'm going to go ahead and do the law of cosines one more time, just for no particular reason other than to do the law of cosines, because it seems like we do law of sines a little bit more often. So in this case, let's find angle B. Okay, so I'm gonna use law of cosines to find angle B. So here B will be equal to the inverse cosine, and in this case it's going to be the 24 squared plus the 14 squared minus the 29 squared over 2 times 24 times 14. Now, if I do everything right, at least as an indication of am I getting something correct, so I'm looking here, angle B is across from the biggest side. So this angle better be bigger than this angle. So let's see what the calculator gives me. And I'm going to go, again, inverse cosine, hit the ratio button, and I'm going to say 24 squared plus 14 squared minus 29 squared, all of it divided by 2 times 24 times 14. And we definitely got a bigger angle, 95.9 degrees basically. So that's going to be angle B. So 95.9 degrees. Now just for kicks, I'm going to go ahead and see what would I get the same angle measurement using law of sines with my saved number here. So let's just do this. We'll say sine of B over the 29 would be equal to the sine of 28.7, over 14. So that means B, when I do my cross multiplication and whatnot, I'm going to say is going to be the inverse sine of 29 times the sine of 28.7, running out of space here, over 14. And ideally, if I type that in my calculator, I should get the same number, 95.9, but of course I want to use my saved number, which I do have it saved in my calculator. So here I'm going to say inverse sine, 29 times the sine of my saved number divided by 14, and hit enter this time. And I'm getting a different angle measurement. Oh no. Well, let me pause the video real quick and make sure I'm not doing something stupid here. Hold on one moment. Okay, so coming back to the problem, because it's been a second since I was looking at thinking about what I was telling you here. But this is the issue that I ran into. I said, well, if you do the law of sines with the calculated measurement that you get here, and you do the law of cosines with the given information, well, they should be the same. And I wound up getting two different numbers, and I said, well, that's not right. And it turns out that it is. It could be either of these, depending on what you're doing. And let me just kind of illustrate what's happening here. Okay, let me grab a sheet of scratch paper here so it'll be clear. All right. In the law of sines lesson, I talked about something referring to the ambiguous case, where I said a side-side angle combination can produce, and I even mentioned it at the beginning of this video, that a side-side angle combination can produce two possible solutions, which is why we never use it for congruency. So I'm going to just freehand this. I know it's not going to be perfect for what we had, but this was A, this was B, and this was C. Okay, so let's just suppose instead of the 28.7 that I calculated, let's say that that was given to me. And of course, this side is still 29, and this side is 14. That's what we were doing to find this measurement here, is we were using law of sines with those values. Okay. And what I didn't see immediately in the diagram that we're looking at here is that this combination, if I just looked at it to begin with this information, that would be side-side angle. So there is possibly two different solutions here. And let me demonstrate what I'm looking at here. So I'm going to do a little bit of construction work with a compass and straight edge to illustrate what's happening. And I'm going to scale the triangle down a little bit. So I'm going to just kind of scale it down by a factor of 3. So 29 divided by 3 is about 6.7. Okay, so I'm going to just draw the longest side length here I'm sorry, not 6.7, but 9.7. So about 9.7 centimeters. I'm going to draw that first side here, about 9.7, right here. Okay, and I'm going to use the protractor. I'm going to just measure off about 28.7 degrees. There we go, 28.7 degrees. I'm going to just measure it. So here's 25, 26, 27, 28.7 will be about right here. Now I don't know how long this side is going to be. Okay, so I'm going to just, okay, because here's A, and somewhere up here is going to be point B. Okay, and point C will come from here. Now point C, if I scale that down using the same ratio, or for this side here, if I say 14 divided by 3, that gives me about 4.7. So what I'm going to do here is I'm going to just give myself, here, let me see, move the paper up. I'm going to just give myself a segment 4.7 centimeters long. And now I'm going to use my compass to copy that segment. So here's about 4.7, okay, right there. And what I'm going to do is I'm going to come here and I'm going to go like so. Now this one is a little hard to see, and let's zoom in a bit here, because what I want to look at is right here. Okay, it's hard to see because the angles are going to be very close to each other, but here you can kind of see that there's a little bit of gap. And if my pencil was a little bit more, like if it was properly sharpened, the gap between this line and this arc would be a little bit easier to see. So what I'm getting is I'm getting an intersection here, and I'm getting an intersection here, where both of those segments are the same length. So again, using the kind of the scaled down version of our numbers here, we started off, we're saying, okay, well this side is 29, so we'll just say this is 29, and this was 14, so this is 14, and so is this. This is also 14. And this angle, 28.7, is the same in both this triangle, ABC, and this triangle, ABC. And what we're getting is two different angle measurements, or sorry, two different triangles where one side is 29, one side is 14, and the non-included angle is 28.7, but that third angle is going to be different. And that's what the calculator was doing when I did the law of sines. The law of sines was giving me the principal value of the angle measurement as opposed to what it could be on a different portion of the unit circle, which I know we haven't talked about, but that's why I'm getting two different angles. So when I did the law of sines using the angle measurements there, I said inverse sine of 20, oh, let me get my ratio button, 29 times the sine of the saved angle, the 28.7, which I still have saved, and I got 84.1 degrees. Well, that 84.1 degrees is going to be one of these two angles here. And the other one that we got according to the law of cosine, so we say angle B is either 84.1 degrees or it's going to be 95 point, I don't remember the number now, 95 point something, about 95.9 degrees. So let's measure that, and I'm going to just turn the paper around so we can try to measure the angle here a little bit. And let me extend these sides out just a bit so it'll be easier to see. So we'll do this one kind of here in pink, and we'll do this one here in green so it's a little easier to see what, oh, and that didn't show up at all. Here we go. And so I just want to be able to turn my paper around so it's easier to see what I'm measuring. Okay, we're measuring from these two angles. Both of these could be point B. Okay, so if I measure from this one here, this looks like to be the 95-degree angle that the law of cosines was giving us. And when I measure here, I'm getting a little off. I'm getting a little bit closer to 100 degrees. And if I measure here, this is closer to the 85, but again, it's a little off, and it's probably having to do with how I scaled it. But there's definitely two different angles that we could have gotten there, and that's what I'm seeing based on the fact that if I was looking at this combination just by itself without the given information in the problem here, side-side angles, that's where we're getting our two different types of triangles from. So based off of the given information, since these were the values that were given to me, I'm going to use the law of cosine measurements. And just out of curiosity, if I take the 24, so I scaled all of the things by 3. If I take this, I should measure about 8 centimeters, and I'm off just a little bit. We're close to about 8 centimeters, but so maybe I messed up on my angle, maybe. But that's why I was getting two different angle measurements when I did the law of sines or the law of cosines or law of sines. So we're going to toss this one out because we'll just use this one because that was using given information with the angle measurement or with the sides that we had here. We're not using any, we didn't use the 28.7, we're just using the given information. And so that's why I'm going to stick with the 95.9 on this one. So sorry, I didn't realize I was going to botch that one up so much, but I'll take it as a learning experience or a teachable moment is what they call it in the business, to say, hey, we made a mistake, but where did we go wrong? It was the fact that with the parts that we had, we're missing some angle measurements. So if we take the difference now of these two angles, and I'm sorry, the difference of 180 along with these two angles, then we can find the third angle measurement here. So if we say 180 minus the 28.7 minus the 95.9, then we'll get about 55.4 for the measurement of the third angle. So 55.4 degrees. Okay. So, well, live and learn. You know, it's expected that they would be the same, but unfortunately in this case it didn't work out because law of sines says that there's two possible types of triangles that we could make where a given side is 29, a given side is 14, and a not included angle is 28.7 degrees. So that brings us here to example number 5. This is where I want you guys to go ahead and try working this one out. You shouldn't really run into the same issue that we saw in the last one, because here you can see we're dealing with an angle-side angle combination. But go ahead and pause the video, try working out the information here to find the missing sides and the angles, and when you're ready, hit play and check your work with mine. All right, and here we go with the last example where they're giving us a diagram to work with. Looking at the figure, we have angle side angle. The missing angle is the easiest one to find. We just subtract the two angles from 180, and we get a 38-degree angle here. And that's the ratio that I'm going to use with the side 6 to find the other two sides. And so the first side I found was about 9.6, 9.598, and the second side was about 8.605. So now let's move on to the application questions, because they are going to, particularly number 7, I want to make sure that you guys try doing number 7, but I'll do 6 and you guys can work on 7 and 8 to see how well you're picking up with the material. On number 6, a wire stretches, what does it say, 30 inches long. A wire 30 inches long is bent into a triangle with sides measuring 6 inches, 11 inches, and 13 inches. So, what do we have? Find the measures of the largest angle in the triangle. Okay? So, that should be simple enough here to take a look at. So I'm going to draw a little diagram for it to see what I'm going to be looking at. So let's take a look at number 6 here. And I'm going to draw my diagram over here just in case I need the white space to do my work. So I'm going to draw my diagram over here. Just a generic looking triangle, nothing special. Where they're saying one side is 11, one side is 6, and one side is 13. So this looks like the smallest side, this is the next smallest side, and the biggest side is 13. So we'll call this triangle ABC, just to give me some kind of a reference with it. And now what it's telling us to do is find the measure of the largest angle in the triangle. So just the one thing, find the measure of the largest angle. So in this case, we're looking for this guy right here. We're looking for the measurement of angle B. So here I'm going to use the law of cosines, and so I'm going to say that the measurement of angle B, according to the law of cosines, will be equal to the inverse cosine of the 11 squared plus the 6 squared minus the 13 squared divided by 2 times 11 times 6. And so here it's just a matter of plugging it into the calculator once you know what the formula is. And go to the calculator here, inverse cosine 11 squared plus 6 squared minus 13 squared over 2 times 11 times 6. And I get 100, and that's not right. Oh, because I did a 1 there, not an 11. Let's try that again. Let's put a 1 there. There we go. That sounds about right. I can't have a triangle with a 180-degree measure in it, so no, about 95.2 degrees is what we're going to be looking at. 95.2 degrees. And there we go. So you, intrepid student in trigonometry, try working out problems 7 and 8. And one of the main reasons why I'm giving you problem 7 to do is because it's giving you the vocabulary term of an angle of depression to work with. Okay, so pause the video, work these out. When you're done, hit play, and let me know what you get. All right, now how well did you do with these last two? Hopefully you're able to get the same answers that I am. On number 7 particularly, I wanted you guys to try it because of the angle of depression vocabulary. Remember, the angle of depression or angle of elevation must be made from a horizontal line. So an angle of depression from Tina would be given 65 degrees here, so that's why this angle is 65. Here, Braden has an angle of depression looking down of 28 degrees. And what it's asking you to do is asking you to find how far is Tina away from the goggles. So that's why I'm saying G here for goggles. In this case, what they gave me was angle, side. But the side that they gave me is across from an angle that they didn't give me. So subtracting the 65 and the 28 from 180 gives me an angle here of 87 degrees. So sine of 28 over x is equal to sine of 87 over 12. Solving for x, about 5.6 feet. Starting from the same port, a ship A and ship B sailed apart with a 30-degree angle between them. So here's my port, 30-degree angles. Ship A sailed 5 miles. Ship B sailed 8 miles. Find the distance between the ships. So we're looking for this side here. So side, angle, side. It tells me I'm using law of cosines. So we set it up the square root of 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 30 gives me about 4.4 miles. So this is going to wrap up the lesson that we have here for looking at how we can just make sure we understand what parts are given to us and using that to determine whether we use law of sines or law of cosines. Paying particular attention to example number 4 here, where it's a good idea to limit yourself to the information that was given to you as opposed to necessarily trying to use a calculated value for something else, because we remember how that one came out. And when it comes to solving a triangle, basically find anything that is missing, any angles, any sides that are missing, make sure you find them. But thanks for watching, guys. Take care and hope to see you soon.